are as real as they appear in the images, or have you added or enhanced to highlight the features and the depths and so on?
Well, it's of course a balance that you have to make. So it's not the real colors in a sense, because if you had the chance to travel to this place, even so, I'm not sure that you want to go there because it's blazing hot, and I'm not sure you will survive very long. But if you would go there and see it with your own eye, you would of course not see exactly what we see here, because as I said, we are associating colors to each individual filters. So to H alpha we are giving red, to oxygen we are going to give green, and we combine those images together. So, I mean, it is almost true color. We try to be as close to reality as possible, but of course it is not exactly like the eye would see.
Yeah. So just to clarify this, all the images...
Brigitte is, sorry. No, I just mentioned that you can see that Brigitte is really into it, and she is really doing the observations. So it's really amazing. So go ahead, sorry. I interrupted you.
No, I just wanted to add to what you just said about the images, that all of the images that we release publicly are all based on actual scientific data. So that's the foundation. The color scheme, like Henri explained, is only an approximation to reality, but it is definitely based on real scientific data, and that's not somehow made up or anything like that.
No, exactly. We know that the oxygen, for example, is of course emitting in the green. That's why we give it green color.
Exactly.
H alpha is in the red part of the spectrum. That's why we give it red. So it's not just that we are making it up. It does correspond. That's why then in the final image, where you see, if you will see a patch of green, you will be able to say, okay, there must be some very hot oxygen. Where you see the patch of red, there must be, in fact, some hot hydrogen. So you will be able to understand the physics and the chemistry of the object by looking at the color in the image.
So while the telescope is integrating and is collecting light from your target, what are you guys actually doing? Do you need to do much? Okay, you're busy now, I guess.
Yeah, sorry, I was just launching the long exposures now because we have now collected small, so we have an idea about the object, what it looks like, so we know also how deep we can go and how much we can integrate. So again, we will do a series of 3-minute exposure in this oxygen tree. So to come back to your questions, well, of course, while the telescope is observing itself, you don't need to do it. Anything, it's behaving very well and it does it all on its own, but we have always to be prepared for the next observation. So we have continuously to look at what kind of observation can we do afterwards, depending on the conditions in the sky. So depending on the quality of the image, depending on the water vapor, and so on. So every time we have to look carefully and prepare, be ready directly for the next observation, which is also why sometimes I am interrupting you and just going to the telescope. It's just a reflex that we have. Never lose a single second of telescope time.
So Brigitte, I just want to come back to you for a second. We've got some footage of you arriving at Paranal, and can you tell us a little bit about how your trip to Paranal went, and was your flight okay and everything, and did you make it safely?
Yes, sure, I'm here. Yes, it was a very nice trip. We had I arrived in Santiago where I stayed for 1 day, and then afterwards we took a plane. I think it was a 2-hour flight, and we saw the mountains. We saw at first there were the fields and very agricultural, and afterwards we saw the desert. Below the plane, mountains, and we even saw Paranal from the plane, from the commercial plane. So it was a nice sight, a nice surprise. And afterwards, it's a 2-hour trip by road, a road trip, and it's just one long road going straight nearly, and it's just a desert on both sides with mountains, and it's an amazing sight. It's like you're on Mars. In fact, it's a good surprise. Very beautiful.
So what did you think of the Residencia? Is it the same as in the movie?
Yes, it is, but it's still a surprise. You know, the colors, a lot of red and the green from the plants near the swimming pool, and it's beautiful. It's very integrated in the scene and in the surroundings, and it's beautiful design and architecture, and it's very nice to live in it. It's a great place to work and to stay.
So we just saw some footage of you walking through the desert there. Can you describe the environment a little bit? What is it like up there on Paranal?
There's little vegetation, just a few plants. Mostly it's rocks, not really sand, really rocks. And you know, it's a mountain. It's a desert on a mountain, so it's quite surprising. It's not usual. It's not something you see in France, for instance. It's you feel on Mars. That's it, basically. It's just what you see. It's and how you feel.
And of course, all the astronomers are little Martians.
I'm not saying that.
So in the meantime, we have already a new observation of 3 minutes exposure. Yeah. I hope you can see it. Can you zoom in? I mean, it's a wonderful object. I mean,
wow,
the public shows really well when they did. I mean, that was really a very good choice.
I didn't vote for it, but he did.
Well, no, I justify my vote.
Yeah, it was a good choice.
So we are now going to do some more exposures in this filter, and then maybe start to continue with a different filter later on.
Okay.
But we will soon have to finish, of course, because the night is really coming to an end here in Paranal. So we still have for about 6 minutes before Rodrigo is going to tell me that we have to close the telescope for safety measures.
So is that when the sun is coming up in about 6 minutes?
No, it is because it takes about 25 minutes to close the telescope, and the telescope has to be closed by the time of sunrise. So in fact, sunrise here will be at 7:10. And that's why 25 minutes before means 6:45. We have to start the procedure to close the telescope. And Rodrigo is going to be very strict about that, so we won't have choice. Because we don't want, of course, to damage the telescope. We want to be able to take many other nice pictures for the years to come.
Can you actually maybe just for 1 or 2 minutes just explain what Rodrigo is actually doing? What's his job and his role there at the telescope?
Yeah, so Rodrigo is the telescope and an instrument operator. So he's really in charge of all the technique, maybe, yeah. So here he's showing on the camera. So he's really in charge of making sure that the telescope behaves very well. He's, as you have seen at the beginning, he's doing the preset when the telescope, making sure that the quality of the image is excellent. And this is what we see he succeeded. And he has, of course, to keep this quality of image during the whole time of integration, so typically during at least 1 hour. And the operator is also in charge of the instruments, and they are normally going to operate the instruments. Even so, we astronomers also like to touch it. So sometimes there is a little bit gentle fight of who is going to play with the instruments. We all want our little toys. So.
Actually, you were just talking about the image quality there. Just so happens that I have a question from a member of the public here via Twitter, and he's asking about how's the main mirror stabilized?
Yeah, so here this is exactly what Rodrigo had done at the beginning. This is what is called the active optics, because you have to realize that these mirrors, they are 8 meters in diameter, but they are only 17 centimeters thick. So if you would bring that to a reasonable size, they would not be, for example, 30 centimeters. The thickness is not larger than a pancake. And this means also that, of course, it is a little bit as flexible as a point cake, which is not so